Hello, everyone. Let's solve another Leetcode problem today. And today's problem is finding the longest substring without repeating characters. This is problem number 3. This is one of the most important problems. And using this problem, you will have a good understanding of sliding window. And this is one of the problems in blind 75 list. So let's go to the problem description. So we're given a string S. We have to find the length of the longest substring without repeating characters. So we have to find the length of the longest substring that has all unique characters, right? Okay. So for example, you see this one, right? This is our string. So let's try to find the substring that has unique characters. Say, suppose ABC, here is a substring, right? You see all of these are like unique characters. And then there is a BCB, that's also a substring, but you see there is a repetition of B there, right? So we have to find the longest one. So ABC is of length 3. And then next is, if I take ABCA, then it doesn't work because there's a repetition of A. So you see here that the answer here is ABC with the length of 3. Okay. So the answer is 3. In the second example, you see all of them are the same character. So the longest substring that I can have with a unique character is of length 1, because I cannot expand to the second character. In that case, the character becomes like the repeated. In the third one, you see, if I take, say, KEW, that is a substring of unique characters, and that has a length of 3. That is the highest, I guess, because otherwise, or you can take like WKE, that is another example, right? But you cannot go beyond 3. So I think WKE is 1, KEW is another. So the answer is 3. Okay, so let's think about how we can solve this problem. I would suggest everyone to think about this and then come back and watch. Let's discuss together and try to solve it together. Okay, so the idea is like, what about we start from the left and try to expand our substring? And you see, if I try to expand my window, in that case, what's going to happen? So this is, suppose, my string, right? This is my string. So what we'll try to do is, I will try to start from the left and try to expand it to the right. That means I will try to have a sliding window that is expanding to the right. And so what's going to happen is I have to expand to the right, keep on expanding to the right, and see if this window is valid. So until this window is valid, say this is a valid window, say. Okay, by valid window means all the characters in this substring is still unique. Okay, so to check the validity, we have to have a map. Say a map. We need to keep a map, frequency map. So frequency map where I will put all the frequencies of different characters. Say A is 1, like Z is 1, E is 1, for example. Okay. Now this map will remain valid until none of the frequencies are like goes beyond 1. So I will keep on expanding the window, and this window is going to be valid until all the characters in the window has a frequency of 1. Okay. And so let's say I expand it even further. So say I expand it. Okay, so let's say I expand it here. Okay, this time, say this window now becomes invalid. It becomes invalid. Okay, so invalid means that one of the character frequencies has become 2. Okay, so maybe this one has become 2. Okay, so before going to that, so until the window is valid, okay, so until the window is valid, I have to, so window was valid here, right? Window was valid here. So until the window is valid, I will keep track of the max window length. So max window length, or that is the actually max length of the substring. So say, for example, let's say I expanded my window to here and still it's valid. Okay, so let's say still my window is valid. So I will update my max window length to from 3 to 4. And then I expand it further. Say I expand it to the next window. So I expand it to here and now it becomes invalid. By invalid means this time one of the character frequencies went up to 2, right? So what I have to do now is I have to make this window valid again. So how can I do that? So I know that this one became invalid because of this character, right? This character. Say this character is anything, say is R or something, right? Okay, so what I have to do is I have to push push my window to the from the left. So far I was expanding to the right. So in this time what I have to do is I have to push this left wall and start to try making it valid again. So it became invalid because of this character R. Suppose R, another R was here, right? So what I have to do is I have to keep on pushing the left wall. I have to keep on pushing, and then I have to update these frequencies. I have to update this frequency map, right? Because say there was say A here, there was A here, then there was Z here, then there was say this one, let's make it R. Then there was say B here, right? B is 1. So I keep on pushing. So once I push here, push the left wall here, what's going to happen is now the frequency of A becomes 0. Then I push the left wall here, right? The frequency of Z is going to be 0. Then I push the wall here. Now you see the frequency of R is going to be 1. That means now the window is valid again, right? So this one now becomes the valid window. Okay, so this one now becomes the valid window. And once I am in the valid window, then I will again try to update my max window length, obviously, and then I will again try to push it to push the right wall. So expand the window again. So the idea is expanding the window to the right, update the max window length, and then keep the window valid, right? Keep the window valid, and to check if the window is valid, we need a frequency map. And if any of the entries in the frequency map becomes invalid, in that case, I just keep on pushing the left wall. That means shrinking the window until it becomes valid. Okay, so that are the cases. Okay, so just to summarize again, we will expand the window to the right and we'll check the validity. If it's valid, then we will update the max window length. We'll keep on doing this until the window is valid. At some point, the window will be invalid, right? It might be invalid because one of the characters repeat. In that case, what I have to do is I have to push the left wall or shrink the window until it becomes valid again, okay? And then I do the same thing, the previous steps again. So let's look at one example. Say ABC, this one, ABC, AB. So let's do this. It was A, B, let's write here, A, B, C, A, B, C, B, B. Okay, so this one was, so say this was a map, frequency map. of the characters. Okay. And then we have a max window length. So initially we'll put max window as say 0. Okay. And then what I'm going to do is I am going to like put left here and right here. Okay. Okay, so initially you see my map is like A1 and max window length is 1. Okay, next I move the right here. That means my sliding window now becomes AB. So I put B's frequency as 1 and it still is valid, right? So I update the max window to 2. Next I move the right to C and update the frequency and the max window length becomes 3. Next I move this to A and now this one becomes frequency of 2, right? So now it becomes invalid. The window becomes invalid. If the window becomes invalid, I have to push the left wall. I have to push the left wall to here, right? And as I push the left wall, I also update the frequency and you see the frequency becomes 1. That means this window is now valid again. So once it's valid again, I again start to expand. So that means I will move the right to B. But you see now again it becomes invalid. So I cannot update the max window. I have to again make it valid. So what I do is I start shrinking the window from the left. So let's say I start shrinking the window to the left. It becomes the left, right? So this one is right. Sorry, this is left. Now this one from 2 becomes 1. This window is now valid again. Okay, so since this window is valid again, I start moving the next. Now see C becomes 2. So this window is invalid again. I have to start pushing the left wall. And C, the frequency of C becomes 1. Okay, and now it's a valid window again, right? Okay, now I try to expand the window further to the right. Okay, now you see that the issue here is now B becomes 2 and the window is invalid, right? Okay, so I have to do the shrinking again. I shrink again. A becomes 0, but still it's invalid, right? I have to shrink further. Now it's valid. Now you see it's valid. Now the valid is like this one becomes 1. So now it's a valid window. Once it's a valid window, I move the right to this. Well, if I move the right to this, you see this one becomes an invalid window. So I just move it, and once the left is here, only then the window again becomes valid. Now I will try to move R, but R goes beyond the string value, so we are done. Okay. And at the end, the maximum length of any valid window is going to stay at 3. Okay, so let's try to code this problem. I will check if this is something you should ask the interviewer, that if the string can be null or it can be an empty string. So in that case, I will just return 0. Okay, otherwise, I will start my solution. So I will keep a map for character frequency. This map is will keep the frequency of the characters. You can also use an integer array of size 128 because of the constraint says it will be only characters and symbols and space. But in any case, even if I use map, the space is going to be constrained because in the worst case, I will have 128 entries maximum. Then I will have a variable max window size. So for that, let's initiate this with integer dot mean value. Okay, so mean value, I initiate this with integer dot mean value, and then my left wall is initially set at, or left pointer is set at 0, and my right pointer is also, let's run a for loop. So my right pointer will also start from 0, and it will keep on expanding until the right pointer doesn't go beyond the length of the string. Every time I will increase for the expansion. Okay, so first thing what I have to do is I have to read the character, the current character from the right pointer. That means character at right. Okay, and then I have to update the frequency of these current character. It may be the case that I am experiencing this character for the first time. That's why I'm using this get or default function. Okay, so so that is the case, and if the window is invalid, then we'll actually handle it here. But if it's valid, then what we are going to do is we will try to update the max window length. You know that current window length is going to be right minus left pointer plus 1, and I will compare it with, again, is the current max window length. Okay, and update it. So this is for a valid one. But if it's an invalid window, what makes it invalid? If the current character appears, like if it's is a repetition, that means it's appearing for the second time. In that case, my sliding window now has a character. This is a culprit character, right? Because of this, it has become a duplicate. So I have to make sure that I push the left pointer to the point so that all the characters again become unique. So that's why I say, like, while map dot get, this is a culprit character until this is 2, right? If any of the frequencies become 2, so I update the frequency, and suppose the frequency became 2. So now I have to make sure that until it is 2, I just keep on shrinking the window. So I will shrink from the left pointer, and before that I have to also decrease the frequency of the character that is in the left pointer or in the left index. So if I decreased it and then I shrinked it. I will keep on doing this until I reach this character and the frequency goes back to 1. Okay. And finally, I will return this max window length. Okay, so let's try to run this. Okay, so I have made a mistake here. Okay, and submit this. Okay, so you see it's actually pretty fast, and the time complexity of this algorithm is going to be, let's say, so the time complexity is going to be order of n. The reason behind this is actually it's order of 2n. So you see this right pointer, this one moved like n times, like, right? So this moved n times, and the left pointer also probably has moved n times. So it's order of 2n, which is order of n. And the space complexity, you can say it's order of n, because there will be at most n entries here. But for these problem, there was a constraint that there like is only can be uppercase, lowercase, and symbols. So at most there can be 128 entries. We can say this is a constant number. So space complexity is also order of 1. And as we said, like instead of a map, you can just keep an array of size 126, 128. So that's it. We'll come back with another problem. Thanks for watching.